Hey guys, good evening. Am I audible? Okay. Yes, let us start the session. Okay. So, good evening, everyone. Let us continue with where we left in the previous session. So, we are currently learning the C module. So, we have got another two classes today and tomorrow. We have to be done with the C module, and then we are going to start with the microcontrollers. So let us continue with where we had left in the previous class. So we were learning things with respect to the functions. So first we got to know things with respect to the pointers, like we discussed something called as the endianness, which is nothing but the byte ordering of a system, then how to write a function, then how to do a functions call, and how to write the definition of the function, how is the function getting executed. So we also got to know the reasons for having a function return. So we can achieve reusability, we can achieve divide and conquer rule, we can achieve modularity. The code can be easily understandable and made modifiable. So functions are easy to be debugged and tested. And we also can achieve something called as abstraction. You can hide the definition of the function. You can hide certain statements which are being executed in a function, which are grouped in a function with the help of a function return separately. So after the advantages of having a functions known, we saw the complete look of the function. Okay. So the complete look was like what is a function call, how does a function definition look like, then what do we call the arguments which are passed to a function. So what do we call the arguments which are collected inside a function. So we discussed that. And what happens if you return a value and you collect it into a variable, what happens if you return a value and you don't collect it into a variable. So that was about pass by value. And we got to know a disadvantage of pass by value, that you cannot return more than one value from a function. So we had to achieve pass by reference. So returning more than one value from a function is not possible with the help of pass by value. And any changes you were making into a variable was into the copy of the variable in another function. So to see that change being done on a variable, return was compulsory. So we saw pass by value where you can return only one value at a time. But in case of pass by reference, you actually make change into the actual variable itself. And because you make the changes into the actual variable, so we are going to look into the function, and once the function is being passed, once the function is being called, and you make the actual variable changed, so you don't have to return the value from a function when you are using pass by reference, and you still can see the change being made on a variable. So that is why we call that that is why we say that more than one value can be returned with the help of pass by reference method of function call. So that is what we saw yesterday, and let us continue with the next thing. So the advantage of pass by references, you can return more than one value from a function. Now the next example we have got is how to pass an array from one function to another function. So we have got arrays. Arrays also have to be passed from one function to another function. Now, please remember one important thing. Whenever a function is being called, so yesterday, for every function which was called, I actually wrote a square box like this in order to make you understand. I actually wrote a square box like this in the previous example, and that is something called as the stack. Okay, so we call it as a stack. So for every function you call, there will be a stack which is getting created. Okay, so whichever function it might be, it can be a main function, it can be a print array function, whichever function you are considering. For every function you call, there will be a stack frame which is getting created. And once the stack frame is created and you execute the function, the stack frame also gets destroyed. So after the function is executed, the stack frame is going to get destroyed. So initially, stack frame gets created when you do the function call. Stack frame gets destroyed when you come out of that particular function. Now stack frame will have the variables whatever you have created, and it also has the return address. Okay, so stack frame will have the variables, also it will have the return address. So return address means the address where it has to get back. Okay, so whenever a function is being called, a stack frame gets created which will have the variables of the function and the return address, as in where the function has to return. Now let us look at a simple example here of passing an array. Now when we were discussing things with respect to an array, do you remember what does the name of the array represents? So we have discussed it already. Do you remember what does the name of the array represents? Is there anybody who remembers what does the name of the array represents? Parameters? No. Anything else you remember? What does the name of the array represent? Okay, yes, it is the address. The name of the array represents the address in which the array is being present. Now I'm making you understand this example where I'm trying to pass an array from one function to another function. So name of the array always represents the address in which the array is present. Now let us see how this program is actually working. I'm creating a blank sheet. I'm having the program copied, and let me also have it copied here. Okay. Now this is the program. Okay. So first we are seeing the prototype of the print array function. So prototype means before I write the definition of the function, I should write the prototype of the function. So I have a prototype of the function written. So the name of the function is print array. What a user is writing is a print array function. The function has a return type called void, and it has a pointer called int array. So this is a pointer, int array, it is a pointer. So I can either write it as int star arr, or you can write it as int array with an empty braces like this. So only in the functions, if you write it like this, it is allowed and it will be treated as a pointer. Now first, the very first function which gets called whenever you are running a program, the very first function which gets called always is a main function. So when main function is being called, the stack frame for the main function has to be created. So this is the main function for which the stack frame will be created. Now after the main function is being called, I will have the variables inside the main function. So the variables of the main function are, there is a variable called array which is having 5 integers. Can you tell me how much is the total memory allocated for this array in the main function? I have 5 integers. How many bytes of memory is allocated for this? Yes. So there is 5 multiplied by 4, a total of 20 bytes of memory allocated. Now this is the address 1000. Okay. Then the next integer is at the address 1004, then 1008, then 1012 and 1016. So I have got 10 return here, 20 return here, 30 return here, 40 return here and 50 return here. Okay, so I have got the values written. Now after this, to the print array function, I am passing array, which is the name of the array. So being in the main function, array is the name of the array, which represents the base address 1000. So 1000 will be passed as an argument. Okay. Now when I call the print array function, so one more stack frame is going to get created for the print array function. So I'm doing a function call. So stack frame is going to get created for the print array function. So this is the print array function, which is having a pointer as the very first argument. So in the print array function, array is a pointer. So there is a pointer called array, and assume the memory for array is allocated from the address 2000 and it is having the base address 1000 received. Because I am passing 1000 here, 1000 is received by the array here. Okay. Then what I am doing is, I am trying to print the array's element with the help of an array here. Now please understand how this is working. Whenever you say array of I or array of iter, compiler is going to see it as star of array plus iter multiplied by size of the data type. Okay, you can just remember this. Whenever you say array of iter, so compiler is going to understand it as, one second. Okay, so I'm writing it here. So whenever you say array of ITR, compiler is going to see it as star of array plus ITR multiplied by size of data type. Now, star of array is nothing but in the print array function, it's a pointer representing the address 1000. So this is going to take 1000 plus, initially ITR takes the value 0. So it is 1000 plus 0 multiplied by size of the data type is integer, which is 4. So initially it is star of 1000 plus 0 multiplied by 4. It is star of 1000. What will it give? So what will star of 1000 give? So it will go to address 1000 and fetch the value. It has to give you 10 printed as an output. So percentage D equivalent will have 10 printed. Then ITR plus plus takes the value 1. 1 lesser than 5 is condition true. Again star of ITR is star of array plus ITR is 1 this time multiplied by 4, which is 1004. So I am going to dereference address 1004, which is going to give me the value 20 printed. So like this, 30 gets printed, 40 gets printed, 50 gets printed. Just remember one thing, you are passing the name of the array as an argument, which is representing the starting address, which is 1000. To collect that address 1000, I need a pointer variable. So this array is a pointer variable. This will be seen by the compiler as int star array. So array is the pointer variable which is receiving the 1000 inside it. Now when I say array of iter, so compiler is going to see it as star of array plus itr multiplied by size of the data type. So it is going to dereferences the address 1000, 1004, 1008, 1012 and 1016, and it is going to give me the values printed as 10, 20, 30, 40 and 50. So that is the output of this program. Let me execute this and show you. So here is the program. I am running this. So you can see index 0 has element 10, index 1 has element 20, index 2 has element 30, then 40, then 50. So this is going to have the elements of the array printed as an output. I hope you got this. Can you look at this example and tell me what is the output? Observe this and tell me what is the output. What will be the output of this? Okay, same as the previous array. Okay. Any other answers? Okay. Now observe what is happening in this program. So I have taken it to this page. So first I have a modify array function which is returned by the user. The function is going to take the array's address. So I collect it into a pointer called array. Then the function is also collecting the size of the array. Okay. So function is also collecting the size of the array. And coming to the return type, okay, of the modify array function, it has the return type as int star, which represents the function is returning an address of integer. Okay, returning an address of integer. So that is what it represents. If you say int star here, it is trying to return the address of an integer. Now first to start with, I have a main function which has an array of size 5. Okay, there is a main function which has the array of size 5. I'm going to copy the same. So this is the main function which is having an array of size 5. Okay. Now here in the main function, so this is the stack of the main function. Here in the main function, there's an array of size 5 which has got the memory allocated from the address 1000. And apart from this array, it also has a pointer variable called new array val. Okay. So it also has a pointer called new array val. So I will take that pointer again in the same main function's stack frame. So the name of the variable is new underscore array underscore val. Okay. So after this, I'm calling the After this here, if you observe, I'm calling the modify array function by passing array and 5 as an argument. So this new array underscore val is, let's say, present from the address 2000, which is initially having garbage value. When I call the modify array function by passing array and 5 as an argument, so one more stack frame for the modify array function is going to get created. So this is modify array. Okay, and being inside this, I have three variables. One is a pointer variable called array. One is an integer variable called size. Another one is an integer variable called iter. Okay, so this is a pointer variable called array. This is an integer variable called size, and this is an integer variable called iter. So array is present in the address 3000, size is in the address 4000, iter is in the address 5000. Now, so array is a pointer variable which is receiving to the modify array function. You are passing array and 5. Array represents 1000 and 5 has been passed. So in the modify array function, array receives 1000, size receives 5, and iter here I have initialized to 0. So 0 will be seen. So now what happens is you're trying to do star of array plus iter plus equal to 10, which means star of array plus iter is equal to star of array plus iter, okay, star of array plus iter and plus 10. Now wherever this to the address you're going to add a value, you always have to remember that it depends on size of the data type also. Okay, so here also it is array plus itr multiplied by size of the data type, which is nothing but integer. So after this what happens is you can substitute and do the operations. So it is star of 1000 plus ITR is initially 0 multiplied by 4 is equal to again star of 1000 plus 0 multiplied by 4 plus 10. Okay. So star of 1000 plus 0 multiplied by 4 is star of 1000 is equal to star of 1000 plus 10. So star of 1000 is representing the value. You go to address 1000 and see it is 10. So here it is 10 plus 10, which is 20. 20 is written into address 1000. So I will end up having 20 return here. Now similarly you change ITR as 1, as 2, as 3, as 4. Then this is going to get changed with 30. This gets changed with 40. This gets changed with 50. And this gets changed with 60. Then after this, you are returning the array. So in the modify function, array is a pointer which is representing the 1000, which is an address. So return array is going to return 1000 to this place where the function is being called. So new array val pointer receives 1000 here. After this, the stack frame is going to get destroyed. Okay. So I understand it is not easy to take things all at once. So pointers needs a little practice, which is why I'm making it a little slow. So you just have to remember these things, what happens. So first I got the main function called, which has an array of 5 integers. Okay, it is this line. Then there is a pointer variable called new array val. So I got that variable declared, which is initially having some garbage value stored. Then you come to this line. Here modify array function is being called. So control will come to the modify array function. Okay. Now being in the modify array function, this is modify array function. Here I have a pointer variable called array. I took that. I have an integer variable called size. I took that. I have an integer variable called itr, that is also taken. Now to the modify array function, you have passed array and 5 as an argument. Array represents 1000 in the main function. So that 1000 is collected by the pointer variable array and 5 is collected by size. ITR is initialized with 0. So that is what I filled in each of this. Now this for loop is running for 5 times because size is 5 here. So where is 3000 coming? So that is the address I'm randomly taking. So array is a pointer which has got memory allocated in the address 3000. Size is a variable which has got the memory allocated in the address 4000. ITR is a variable which has got the memory allocated from the address 5000. So I'm randomly taking the addresses and I'm going to have the data stored inside it. Now, after this, what happens is I'm doing star array plus ITR plus equal to 0. So whenever you're doing this, so previously also when array plus ITR was seen, I told array plus ITR will be seen as star of array plus ITER multiplied by size of data type. So here also I am doing star of array plus ITER, which means star of array plus ITR multiplied by size of data type. So it is something called pointer arithmetic, which cannot be taken in detail. So I'm just helping you out to remember this. So when this plus equal to means star of array plus ITR is equal to star of array plus ITR plus 10. But always when to the pointer you are adding something, it depends on size of data type. So I did size of data type here, size of data type here also. So star of 1000 plus 0 multiplied by 4 is equal to star of 1000 plus 0 multiplied by 4 plus 10. When I perform this operation, I end up writing 20, 30, 40, 50, 60 into the array. Then I am returning array. In the modify array function, array is a pointer which is representing the address 1000. So that 1000 is returned and I am collecting it into a pointer variable called new array VAL. So 1000 gets collected here. Okay. Then I am calling print array function by passing new array VAL, which is 1005. So this is going to receive 1005 and this function is same as this function which we executed. So this function is going to print the value of array. So 20, 30, 40, 50, 60 will be printed. Got it? Okay. So can array of ITR and star of array plus ITR be used interchangeably? Yes. So in fact, star of array of ITER is anyways been seen by the compiler as star of array plus ITER. Okay. So this array of ITR is always seen by the compiler as star of array plus ITR. So yes, you can interchangeably use both of them. So both of them represent the same thing. Okay. So the output of this program is 20, 30, 40, 50 and 60. You can note this down. We will take 2 minutes of break and we'll continue. Okay. What is it? Related to the function call, there is nothing different, guys. Like whenever you're doing the function call, this is the function call you're observing. So I'm doing one function call here, one more function is called here. When modify array function is being called, I'm passing array and 5 as an argument. Okay. So array is the name of the array in the main function, which represents 1000. So 1000 is being passed and 5 is passed, which is collected by a pointer and an integer variable called size. Then I'm calling one more function called print array by passing new array val and 5. So new array val is representing 1000. So for this also I'm passing 1000 and 5 as an argument. Okay. So I have repeated the same for twice. You please go through the recorded session like if you missed anything. Okay, very similar to this, we have one more example. Observe. Okay, there's one more example here. So can you tell me what is the output without seeing the static keyword? So don't see the static keyword, just say what is the output in this example. Why did we use void print? Okay, the reason for using void print is from this print array function, if you observe, I'm not returning anything. So because there is nothing being returned here, as the return value is nothing, I'm keeping the return type as void. Okay. Now we will go with a similar kind of example, but before that, let me execute this and show you the output. So this has to give me 20, 30, 40, 50 and 60. You can see 20, 30, 40, 50 and 60. Okay, where to get the recorded video? It will be in your LMS. Now proceeding ahead with one more example here. Okay, I'm copying and let me paste it here and also here. Okay, so this is one more example, a relative example to the previous one, and listen carefully. So it is very similar to that. Okay, now this is the program. Okay, so first what happens is I have a main function. Okay, so where can I get the recorded video? There is LMS for you. So you must have got the login credentials for it. So this is your LMS. You will see something similar to it, the Moodle platform. So you have something called as internship provided, and under that internship you will be able to see all of that. One second, let me show you that. I have multiple things, so I cannot list it. Okay, here. Okay, so in this LMS you can get all the recorded videos. All the recordings of the videos are being provided here. Okay, the downloading software video, I think it must have got updated. Okay, so that if it is not available, I'll inform. Yes, that is not updated yet. So that will be added soon by today. Okay, I'll inform. So that has to be added. The project will be given shortly. Like once you are done with the module, we will give you the project. Okay. So all right, let us continue with the next example here. So this is the next example you have got. And being in this example, first to start with, I have a main function. And in this main function, this is the main function I'm taking. In this main function, I have got a pointer called array underscore val. So this is the main function. There is a pointer called array underscore val. The weekly quiz, it will also be provided once you're done with the module. Okay. So here we have something called as array underscore val, a pointer. Assume it is present from the address 1000 having some garbage value initially. Now array underscore val is expecting something from a function called return array. So I am going to call the return array function here. The return type of the function is int star because it is going to return the address of an integer. Now return array function is being called. Okay. And when the function is being called, again the stack frame should be created. So this is the stack frame of the return array function. One second, I'll copy it because it's similar. Oh, so give me a second. The software is not responding. Okay, the software is not responding. Let us continue with this itself. So now what happens in this program is I am calling a return array function. Inside the return array function, I am taking an array. So just assume this is the array of the return array function, which is initially having the value 10, 20, 30, 40, 50. Okay. So I think I can go with this itself. So there is a return array function which is having the array called array of size 5. Assume it is from the address 2000. So from the address 2000, I have the values return, which is nothing but 10 here, 20 here, 30 here, 40, 50. So up to 50 here. Now after this, I'm saying return array. So array is nothing but the array in the return array function, which represents the value 2000. So 2000 gets returned into this pointer variable. This place gets replaced with 2000. So array underscore val receives the value 2000. Okay. Now I'm again calling the print array function by passing 2000 as an argument and 5. So that address 2000 is collected by the pointer variable in the print array function. So it is 2000 and size is 5. Now this loop is running for 5 times. Okay. The loop is running for 5 times. Now it is array of I. So it is 2000 of 0, 2000 of 1, 2000 of 2, 2000 of 3, something like that. Now the problem with this is whatever the address 2000 is there, okay, so whatever address 2000 is there, that is not a part of your program, okay. So that was actually a part of your return array function. This array what you wrote was a part of your return array function. So this address 2000 is not yours right now because you are not in the return array function. You are in the print array function. Being in the print array function, if you try to access address 2000, it will give you an error called as segmentation fault. Now observe, I am executing the code. So you can see here, there is a warning, and apart from warning, when you execute this, you will end up getting an error scene. Okay. So that error as of now is not showing if you execute it in the actual platforms, it is going to give me an error. Now, in order to not see an error, you want 10, 20, 30, 40, 50 to be printed. So I have to go with something called as static array. Now, what this static does is, the memory for this array will be allocated in something called as the data segment, and that array will be with the user until the program gets terminated. So previously what happened here was, this array I declared was visible only to the return array function. So this address 2000 was only with the return array function. When I came out of the return array function, this address 2000 was not with the programmer. Because you are done executing the return array function, this address 2000 was not with the programmer. Which is why when you tried accessing address 2000 here, it was giving you an error. Now to overcome this particular error, I had to write a keyword called static. So when static is being returned, this array gets the memory allocated in something called as the data segment, or I can say this memory allocation happens in such a way that it is visible to the complete program. So wherever you are, it is visible. Now being in the print array function, if you access address 2000, it will be allowed and it is going to give you the output printed as 10, 20, 30, 40 and 50. So observe this. Now when I made it static, you can see the output as 10, 20, 30, 40, 50. So static is a keyword which makes us access the variable anywhere throughout the function. Okay. So that was about the static array. Okay. So apart from that, you also have one more thing called as a recursive function. So what do you mean by a recursive function? What do you mean by a recursive function? Function calling itself, correct? Any other answers? Method calls itself. Method or function represents the same. Okay. Then which occurs repeatedly. Okay. Function that calls itself, fine. Repeated. Okay. So yes, recursive function means the function which calls itself. Okay. On a repetitive manner, we call it as a recursive function. Any function which calls itself on a repetitive manner is called as a recursive function. Now, what is this recursive function, or how to get this recursive function done? Now, if you observe here, okay, so we have a simple example of recursive function. Whenever you have to write a recursive function, you have to be aware of two things. One is identification of the base case. The other one is writing a recursive case. Now observe an example of the recursive function here. So let me make you understand how this is working. So I'm closing this program and opening this again. So I want you to understand how this recursive function is working. Now first what happens is, I call this a recursive function. As you can see, the factorial function here is called by itself. I'm calling the function being in that particular function itself, which is why we call it as a recursive function. Now let us trace how this is actually working. So to start with, first there is a main function. Okay, so I am here in the main function. Now in my main function, okay, I have certain things written. One is an integer variable called result. So result gets created. I am doing result is equal to factorial of 3. Okay, I'm doing result is equal to factorial of 3. Now this factorial of 3 is a function call. Okay, so factorial of 3 is a function call. So I will take you to the function call of factorial of 3. Okay, now when it is factorial of 3, okay, so what are you doing is you are checking if number lesser than 1, condition true or false. Number lesser than 1, condition true or false, it is false. So 3 less than or equal to 1 is condition false. So you go to the else block, there is return number. So number here is 3 multiplied by factorial of 3 minus 1, which is 2. Okay, so I'm executing the program here. So first there is main function. Okay, when main function is being called, so the very first thing I did was I called the factorial function. Being in the main function, we called the factorial function. So it was factorial of 3. You called factorial of 3. Number collected was 3. 3 less than or equal to 1 is condition false. It went to the else block. Return 3 multiplied by factorial of 2. Now again factorial of 2 is one more function call. So I have to write it for factorial of 2. So this is factorial of 2. Okay. Now number collected by factorial of 2 is 2. If 2 lesser than or equal to 1 is again condition false. So it goes to return 2, number is 2 multiplied by factorial of 1. Okay, so it is 2 multiplied by factorial of 1. Now again, factorial of 1 is one more function call. Okay, this is factorial of 1. The number collected is 1. So, number less than or equal to 1 is condition true. It says return 1. So, where is 1 return is to the place where factorial of 1 function is called. Okay, so 1 gets returned to the place where factorial of 1 function is being called. So factorial of 1 function is being called in 1 second. So factorial of 1 function is being called at this place. So this place gets replaced with return 2 multiplied by 1. Now again there is a return. So where is this return returning? To the place where factorial of 2 is called. So here it returns 2. So again there is return 2 multiplied by 3. So where is, return 3 multiplied by 2. So that returns 6 to this place. So result is going to collect it as 6. When you print the result, you will get 6 printed as an output. So I have tried it representing as simple as possible. Okay. First you call the main function. There is factorial of 3 function called. So you came to factorial of 3. Number less than 1 was condition false. You went to the else block. There is return 3 multiplied by factorial of 2. You don't know what is factorial of 2. So you did a function call. Factorial of 2, again factorial function was called. 2 lesser than 1 is condition false. So it was return 2 multiplied by factorial of 1. Again you don't know what is factorial of 1. So you went to the functions call. So 1 lesser than or equal to 1 was true, return 1. So where is 1 return? To the place where factorial of 1 is called. So it was at this point. So return 2 multiplied by 1 is 2. Where is 2 returned? To the place where factorial of 2 is called. That is here. So 2 gets returned. Then return 3 multiplied by 2, which is 6. So 6 gets collected here. result is going to receive 6 and 6 can be printed as an output. How can it be executed 3 times? There is no for loop only. How is this going through? So as you are seeing inside that function, you have a function call, which is why you are seeing the function call being done for multiple times. So inside the factorial function, you are calling a factorial function. So that is why it is doing the function call every time. Understood how this program is working? So let me copy this, execute and show you the output. Okay. So you can see 6. How return works is return is a keyword. It returns the control to the place where it is called. Okay. When I said return here, it has to return a value 1. Return literally says give out the value. Where will that 1 go is wherever the particular function is called. I'm telling return 1 being in factorial of 1 function. Where was factorial of 1 function called? It was at this point. So 1 got returned. Okay. Why return went to the third time function call? So I'm telling when return 1 is said, okay, I'm returning 1 being in factorial of 1 function. So the 1 has to be returned to the place where factorial of 1 function is called. So it is called here. So return 2 multiplied by 1. Now again I'm saying return being in the factorial of 2 function. I have to return it to the place where factorial of 2 is called. So return 3 multiplied by 2. Again 3 multiplied by 2 is 6. 6 had to be returned to the place where factorial of 3 is called. So here 6 gets returned. So result is going to be 6 printed as an output. So that is nothing but a recursive function. Is that clear? Okay. Now let us proceed with some of the runtime errors you come across while pointers are being used. Now, segmentation fault is a very commonly seen error if you are trying to access an address which is not yours. Okay. So whenever you try accessing an address which is not yours, it ends up giving you a segmentation fault. Now, the very first thing if you observe here is a segmentation fault occurs when a program attempts to access the memory location that is not allowed to be accessed or attempted. Okay. So segmentation fault means the one, okay, which is going to the one which is going to be obtained whenever you are trying to access an address which is not yours. So if you observe an example here, the number is initially 0. Okay. So I am trying to read an integer from the user. So what should be passed as an argument to the scanf function? What should be passed as an argument to the scanf function? It had to be address of num in fact. Okay, you had to pass the address of num. But instead of you passing the address of num, you are just passing num here. And the num here is representing the value 0. Okay. So num here is representing the value 0 here. Now when 0 is passed as an argument, whatever user enters, it is returned into address 0. Having some data return into address 0 is not allowed, or reading some value from address 0 is also not allowed. So writing some value into the address 0 is not allowed. Reading some value from the address 0 is also not allowed. But you are trying to do it, you will end up getting an error called as segmentation fault. Okay. Similar to that, we are doing the same here. Int star num is equal to 0. Num is a pointer variable and num is having 0 stored inside it. When I say star num, it is star 0. You're trying to go to address 0 and fetch some value. So getting something from the address 0 again is not allowed. So this also gives you an error called as segmentation fault. So whenever you are trying to access an address 0 which is not yours, or any address which is not yours, so you are going to get a segmentation fault seen. So that is segmentation fault. Then there's something called as wild pointer, which we have already discussed. So wild pointer is the one, okay. So wild pointer is the one which is pointing to some random address, okay. So we saw it yesterday. There will be a uninitialized pointer which will be pointing to some random address. So this is called as a wild pointer which is pointing to some invalid address. This is not a wild pointer because when you take it as static, when you take a pointer as static, by default, the pointers will be initialized with 0. Okay. So this is going to have garbage value, and that garbage value is an address. The pointer will be pointing to some random address. So that is going to consider as a wild pointer. But this is not a wild pointer because you are pointing to an address 0. So it is a valid address. Whenever you take a static pointer, so it will initialize the pointer to 0, and you are trying to point to a valid address 0, and hence you don't call it as a wild pointer. So whichever pointer you initialize to 0, what do you refer it as? Any pointers you take, you initialize to 0. Yesterday we did that. We took pointer which was initialized with 0. So we call such pointers as null pointers. Okay? Yes. So we call such pointers as null pointers. So this is not a wild pointer. Then we have something called as const. Okay. Now what const says is, const is a keyword, okay, which is going to tell the compiler that you're going to keep the value as constant. Okay. So const is a keyword which tells the compiler that you're going to keep the value of that particular variable as constant. Now assume I take something like this. Const int num is equal to 10. Okay. So here number is constant and it is always represents the value 10. Okay. So always represents the value 10. So you can never change this num. You can never do num is equal to 20. You can never do num is equal to 30. So this is not allowed. It is invalid. Okay. So the value of num can never be changed. So that is why you call it as const. So const int num equal to 10. It is a constant integer. Now there is int const star ptr, okay, is equal to address of num. So I'm taking a variable called num here. Okay. Num is assigned with the value 10. I'm doing int const star ptr is equal to address of num. So if you are supposed to read this, I have a pointer variable called ptr. But before that, first I'm taking an integer variable called num. I'm taking a pointer variable called ptr. So this is num return present in the address 1000. This is ptr present in the address, let's say 2000. So num is having some value 10 stored inside it. To the ptr, I'm assigning address of num, which is 1000. and pointer will be pointing to that particular address. Okay, something like this. Now, what is constant here is star PTR. Star PTR is constant. Okay, so you cannot change the value of star PTR. So you cannot do something like this. Star PTR is equal to 100. So this is invalid. So changing the value, whatever pointer is pointing to, with the help of star PTR is not allowed. It is invalid. Now similar to this, you also can take const here. Int star const PTR is equal to address of num. Okay. Now assume there is num1 with the value 10 and num2 with the value 20. Okay. So PTR here is constant. PTR here is constant. Okay. And you cannot change the address. So PTR here is constant. You cannot change the address of the address stored in the pointer. Okay. So you cannot do something like this. PTR is initially having address of num1 stored. You cannot make PTR store address of num2 again. Okay. So that is not allowed. You cannot make PTR store address of num2. That is not allowed. So PTR here is constant. You cannot change the address stored inside the pointer variable. Changing the value of PTR is not allowed. Here pointer is constant. Here value is constant. So star PTR is constant. You cannot change the value of star PTR. So here PTR is constant. You cannot change the address whatever is stored inside PTR. So this is invalid. So that is about the constants. So you have a number taken as constant. You can take a pointer taken as constant. You can take the value whatever pointer points as constant. So that is the const keyword. Okay. So next we have got to start is with strings. Let's take a break of 2 minutes and continue. Okay, so let us continue where we will get the recorded session. So you will get it here in the LMS. So you have the login credentials, I hope, and you will have the recordings available there. Okay. Now let us go to the next thing, which is nothing but strings. So strings are just nothing but an array of characters. So if you go with a non-technical example, a string is nothing but a set of things tied or threaded together on a thin cord. So you will have a thin cord, you will have the thread, okay, so which is tying all the bits together. And if you take a string, so it is going to have a start point, it is also going to have an end point. So any string you take, so it will have a start point and it will have a end point. But when it comes to the string with respect to embedded programming, I mean in the C programming, it is nothing but a continuous sequence of characters. So string is nothing but a sequence of characters arranged on a continuous manner, and it is going to store the ASCII and its extensions. Okay, so it is going to store the ASCII and its extensions. Now end of the string is always marked with a special character called null. So if you just take a character array, that you cannot call it as a string. So a string will always have a special character called as the null character. And for any string you specify in double quotes, the null will be added implicitly. So this is called as null character represented by \0. For anything you specify in double quotes, null is implicitly added by itself. You don't have to add it externally. So null gets added implicitly. So that is nothing but a string, which is a continuous sequence of characters. Okay. So these are the different ways of doing the strings initialization. So first, if you see, there is a character array of a size 5 initialized with the 5 characters H, E, L, L, and O. So every character is being specified by single quotes. Okay. So there is a character array of size 5 and every string is being specified in single quotes. Okay. Now this is not a string because at the end you are not having a null character. Okay. So at the end there is no null character available. So you call it as just an array of characters, a character array, and it is not a string. Now this str of size 6 gets 6 bytes of memory allocated, and it is going to have 6 characters written inside it. Character H, character E, character L, character L, and character O, terminated with one more character called the null character. Now because there is a null character here at the end of str, so this is considered to be a string. It is a valid string. So there will be 6 bytes of memory allocated for this character array called str, and I am going to have H, then E, okay, then there is L, and there is O with the null character. Okay, so because there is a null character at the end, you can consider it to be a string. Similarly, scenario number 3, you already know when you are doing the initialization, specifying the size is not necessary, it is not compulsory. I am initializing it with 5 characters H, E, L, L, O with a null character. So I am initializing it with 5 characters and one more character called as the null character. So how many bytes of memory will be allocated for this str? How many bytes of memory is allocated for this str? There will be 6 bytes of memory allocated because I am going to initialize it with 6 characters. So H, E, L, L, O and a null, I have got 6 characters. Okay. So because I have 6 characters, so str is going to get 6 bytes of memory allocated, and I can consider it as a string. Then this is not a string. Okay, this scenario is not a string because anything specified with double quotes will have a null added implicitly. Ma'am, is it necessary to allocate space for a null character? Yes. So that null should be a part of the array. Only then you call it as a string. If that null character is not a part of the array, you will consider it to be an array of characters only. So null also occupies 1 byte of memory, and it is necessary to give a separate space for the null character also. Null character is counted in bytes. Yes, when the memory is getting allocated, so it will allocate for the null also. So 1 byte for null also will be allocated. Now this is not called as a string because can we add char star str7 is equal to hello with single quotes? No, that is not possible. Okay, so something return hello with single quotes like this, it is not allowed. Okay, so when you write hello with single quotes, something like this, single quotes is always specified to have one character indicated. So with single quotes you cannot do. If you want, you can go with double quotes. That is fine. Okay, using double quotes is fine. Using single quotes is not allowed. Okay, fine. So this is not this is an invalid scenario. Okay, so this is considered to be an invalid scenario. So now what happens with this is there is h with a null character. Okay, because you have specified it with the double quotes, there is h with a null character along with it. So there is e and a null character, l and a null character, l and a null character, o and a null character. It is not just a single string, it is multiple strings you have taken. So this is in fact an array of strings, which is an invalid option. Okay, so this is an array of strings, which is an invalid option. Ma'am, so single quotes hello is not a string. No, you cannot write anything in single quotes here. Okay, multiple characters cannot be written in single quotes, so that gives you an error. And this is fine. The reason why this is fine is when you say h return with double quotes, okay, there is no comma being the separator. First h with the null character is returned. To the place of null character, this e with the null is going to get stored. Okay, so in this place, there will be e return with a null character. Okay, there will be e return with null character. Then to the place of null, there will be L return with null character. Then there will be L again return with null character. Then there is O return with null character. Okay. And after this, there is null also you are going to write. So here the strings are combined together. We call it as string concatenation. Okay. Strings are combined together. We call it as string concatenation. So at the end, this will be seen by the compiler as hello with a null character. Okay, hello with the null character. That is being stored inside str of size 6. So there will be an str which gets 6 bytes of memory allocated, and there will be hello stored like this in those 6 bytes. So this is considered to be a valid scenario. Okay, so there is an array of characters terminated with a null character. So this is right. This is also right. There is an array of size 6 which is written with 5 characters hello, and because you have written it in double quotes, there will be null added for that also. The representation is very similar to this. Okay, So this is also right and this is also right. So all of these representations are like this itself. STR gets 6 bytes of memory allocated. I'm having hello return in double quotes means character HELLO and a null character will be returned. All of these scenarios. But in this, okay, in the last scenario, what I'm taking, let me show you. Okay, so in the last scenario I'm taking, there is a pointer variable called str. Okay, there's a pointer variable called xtr. So this is str. Assume it is present in the address 1000. Okay, so somewhere in the memory block there is hello stored. So somewhere in the memory block there is hello stored. H, then E, then L, and O with the null character. Okay. So now what happens is, so I am going to have this data stored like this. So H, E, L, O with the null character. Okay. So this is str. This is, let's say, present in the address 2000. So this str is going to get 2000 stored inside it. So there will be 2000 stored inside it. And there will be the pointer which is pointing to this particular address. So that is this representation. Char star str is equal to hello. There will be str, a pointer available in the address 1000. So a string will be present in the address 2000. That address will be stored inside the pointer variable str here. Okay. So that is nothing but the third way. And since character has 1 byte of data, will storing hello result in an error? No, I'm taking is an array here on the left hand side. Every situation if you observe, on the left hand side I have is an array. So because I have an array here on the left hand side, so remember it is not going to give you any error. If we specify size 7 and hello null, then what is present with the 6th index? So there will be a 0 return. So you know when an array is been partially initialized, so the rest of the elements will be filled with 0. So 0 will be filled by default. Okay. And what is star str? So star str means it's a pointer variable, character pointer str, which can store the address of a character. So I will get hello memory allocated somewhere in the memory block. Its address is held inside the pointer variable str. So these are the valid ways of declaring an pointer str. I hope you are getting this. And if not an array, then will storing char th is equal to hello result in an error? Yes, it obviously results in an error. When you try storing multiple characters, you cannot store it in a single character variable. It will give you a error. Okay. Now, if you observe here, what is the length of char str6 is equal to hello. So it will get 6 bytes of memory allocated because you are specifying 6 there. So 6 bytes of memory will be allocated. What will happen when it is address of str? Venkatesh, for what are you asking address of str? What is the difference between arrays and strings? So array will be just a character array. It will have multiple characters only. There will not be a null character present at the end. In string, the end will be represented by a null character. Okay, fine. Let me proceed with the next. So I have got it here. So there is a character array of size 5. So 5 bytes of memory will be allocated, and I'm going to have hello return inside it. So H, E, then L, and a O. So 5 bytes of memory is allocated. So when I say size of character array 1, there will be 5 printed as an output. What happens when it's a char star str in, okay, char address of str, you cannot take something like that. There is no way you can declare a variable as address of str. So that is not there. Okay. So writing char address of str is never happening. It will give you a error. Now, why do you think this Sizeof is giving you 6 as an output? Why do you think this is giving 6 as an output? It is a string, correct? So does that mean it has to give 6? Yes. So along with HELLO, I also have a null character added at the end. So I am writing 6 characters into this character array. So there is 6 returned as an output. The size of character array 2 is 6. Now why is this giving you 4? Why is this giving you 4 saying it is a 32-bit system? Okay. Now this str, in this way of declaration, str is a pointer. Okay. In this way of declaration, str is a pointer. Now because it is a pointer, size of str should give you size of the pointer, which is 4 in a 32-bit system and 8 in a 64-bit system. So when I say cat star str is equal to hello, I'm saying size of str. So str is a pointer variable which is representing 4 in a 32-bit system, 8 in a 64-bit system. The size of str considering a 32-bit system will be 4. Okay, so that is str. Now can you tell what gets printed as an output here? What gets printed as an output? Okay, so WAF is been printed, the code before this one. So we saw the representation here, cat star str is equal to hello. So the representation will be something like this. So star str will be a pointer variable and hello will be present somewhere else. The address will be held inside the pointer variable str. So when I say size of str is a pointer variable. So sizeof will tell how many bytes of memory will be allocated for the pointer variable str. So pointer gets 4 or 8 bytes depending on the bitness of the system. 4 in a 32-bit system and 8 in a 64-bit system. So I will get 4 or 8 depending on the system. In my system is 64-bit, so I will get 8 if I print this. So in a 32-bit system, you will get 4. Yes. Coming to this, most of you are saying her, some of you are saying wow. Now the reason what you get as an output is a her here. Okay, so this is the output, this is wrong. Because I am specifying two strings, hello world, and there is no separator between the two. Okay. So when there is no separator between the two, there will be string concatenation happening. Okay. So there will be a string concatenation happening whenever there is no separator between the two. So what happens in this case is I am going to get the string concatenated. So there is hello with the null character because I have something specified in the double quotes. This null gets replaced with the next data, which is world and a null character. So size of hello world will give me, because I have 11 characters, size of hello world gives me 11. Coming to this, size of hello gives me 6 and size of world also gives me 6. Because I'm specifying something in double quotes, there will be one character called null added implicitly. So 6 plus 6 is 12. 11 equal to 12 is condition false. It goes to the else block and has a her printed. Okay. So 11 equal to 12 is condition false. So it is going to the else block and have a printf executed, which is her. Ma'am, all the character arrays are string. No. So only the one which will be terminated with the null will be considered as a string. Can you tell how is it 11? So I'm showing here. You have a string called hello. You have a string called world. So both hello and world will be concatenated. Okay. So hello and world will be concatenated. So you are combining two words, hello, world, and world is having a null character. If you count, there are a total of 11 characters. So size of hello, world together will be 11. Size of hello individually will be 6. Size of world individually will be 6. So 11 equal to 12 will be condition false. All those examples you gave of character arrays are string with a null character at the end. Yes, all these examples will be considered as string except this one and this one. All others are strings because I have a null at the end. Is it mandatory to write return statement at the end? I mean, we just need to print it, right? Then why return type? So, as we have already discussed, returning 0 from a function, especially the main function, represents the successful termination of the program. To indicate the operating system that the program got terminated successfully, so we are going to write return 0. Now, if you see, there are some of the built-in functions with respect to the strings. So there are certain built-in functions here. So when it comes to the built-in functions, we have several types of built-in functions associated to this strings. Let us discuss one after the other in short. So I will just briefly go through what these functions does. The very first function is strlen, which is used to find the length of the string. Okay, so we have strlen, which is used to find the length of the string. Now, to the strlen function, you have to pass the address of the string where it is found. It gives me the length of the string excluding the null character. Okay, so for example, if there is hello with the null character, strlen gives me the size as just 5 because strlen knows every string will have a null character at the end. So why to choose a string with a null character? Okay, so why to count null as a special character, it seems. So if you are using a built-in strlen function to find the length of the string, it gives the length of the string excluding the null character. Now strcmp is a function which is used to compare two strings. So if there are two strings, you are going to compare two strings with the help of strcmp function. So you are going to pass the addresses of the two strings as an argument. strcmp function returns a value. If the value is lesser than 0, then string 1 is lesser than string 2. If the value strcmp returns is greater than 0, then string 1 is greater than string 2. If the value strcmp returns 0, then string 1 is equal to string 2. So you are going to pass the addresses of two strings as an argument to the strcpy function. So it is going to compare the two strings and return a value. If the value returned is lesser than 0, then string 1 is lesser than string 2. If the value returned is greater than 0, then string 1 is greater than string 2. If the value returned is equal to 0, then string 1 is equal to string 2. So that is strcmp function. Then we have strcpy function, which is used to copy two strings. Comparison in terms of size of alphabets. So not size of the alphabets, size of alphabets will always be 1. So the comparison is with respect to the alphabets of each character. It compares the alphabets. For example, there is, let's say I'm taking Ram as one string. I'm taking Ram the same as another string. So R and R will be compared. A and A will be compared. M and M will be compared. So here the strings are equal. So it gives 0. Now, if the strings are not equal, let's say I take Ram and I take RAM. Okay. So now R and R, they are not equal. This is uppercase R, this is lowercase r. So it returns a value. In this case, it returns a value lesser than 0. So I will say string 1 is lesser than string 2. So it compares character by character. And why it is constant? So const wherever you see, that means you are not going to modify the string. So here you see const, you are just taking the string to find the length of it. So you will never modify that string. Here also you are taking two strings to just compare. You will never modify the string. So that is why we have a const here. Then strcpy is to copy one string to another. First one has to be destination, second one has to be source. To the strcpy function, the first argument you pass is destination, the second argument you pass is source. So anything in the source will be returned to the destination. Whatever you pass in the source will be returned to the destination. That is strcpy, which stands for string copy. Then str is a function which is used to search for a substring inside a main string. Okay, so str searches for a substring inside a main string. So for example, let's say there is hello, how are you all, and you want to search for how, if there is how present inside this big string. Okay, so that is done with the help of str function. So if the string you are searching for is available in the big string, it returns an address. If it is not available, it returns null. Okay, so str is to search for a substring inside a big string. Similar to str, we have strchr also, which is used to search for a character inside a string. Okay, to search for a character inside the string, We make use of strchr function. So for example, let's say this is how are you have taken as a string. You want to search for character A. If it is found, that address will be returned by the strchr function. If it is not found, it returns the null. So that is strchr. Then you have strcat, which is string concatenate. So it is going to concatenate two strings. So for example, let's say destination has world, destination has hello, and source has, let's say, world. Okay. So now what happens is this world will be concatenated with hello. That is the destination, and you will end up seeing hello world as an output. Okay. So you will end up seeing hello world as an output. So cat star destination and constant character pointer source. So whatever is in the source will be concatenated to the destination. So destination already has hello, source has world, world gets added to hello in the destination, and you will see hello world as an output. So these are some of the library functions which are associated to the strings. Is that clear? Okay, fine. Let us continue with the next. So after this, we have something called as storage classes to be discussing about. If in strchr 2h are present in the string, then can it say how many h's are present in the string? No, that is not possible. So it will just say the first position where h is found. Okay, so it will just say the first position where h is found. So this is the question. Let me paste it here and tell what is the output. So if in strchr 2h are present in the string, then can it say how many h are there in the string? As I'm saying, no, it cannot. So it can just tell the first place where the string is found. Ma'am, destination pointer should be constant, right? No. So if you take destination as constant, okay, if you make destination as constant, you cannot add the world to the hello. So if destination is made constant, you cannot add it. So that is not possible. You cannot make any changes to the destination here. So that is why it is not considered to be constant. Is that clear? Okay. So I will just give a small introduction with respect to the storage classes today. So because tomorrow we have to finish the module, let me just give a small introduction today as I have some time left, and then we will proceed. So when it comes to the operating system, whichever you are working, generally when it goes to the Linux operating, so the memory is splitted into two sections. One is user space, the other one is kernel space. Okay. So user space is the one which we being the normal users can access. Okay. User space is the one which we being the normal users can access. Kernel space is the one which is dedicated for the operating system. Okay. Kernel space is always dedicated to the operating system. Now, if we have to access the kernel space, we always have to be a super user. In order to access the kernel space, you have to be a super user. And being super user is not something which is possible most of the times. So let us not concentrate on kernel space. If you try accessing a kernel space, you end up getting a runtime error called as the segmentation fault. Okay. So we cannot access the kernel space. We being the users can access only the user space, And let us now concentrate only on the user space. Now in the user space, there can be n number of processes running. Okay. So in the user space, n number of processes. Processes means, let's say you have an MP3 player running, you will have a browser running, you will have a video player running, you will have a notepad running. So every application running can be considered as a process. One among this is your C program. So your program, if you are executing, that also is a process. Now, whenever a user is getting a process executed, there will be certain bytes of memory allocated for a process. So if there is a process running in the system, there will be some memory allocated for the process, which is split into 4 segments called as the text segment, the stack segment, the data segment, and the heap segment. So we will have 4 segments, the text, stack, data, and heap segment. Now what are stored here in the segments is the question. Text segment is the very last segment which will have your code written. Whatever program you have written will be stored here in the text segment, which is also called as code segment. And you cannot do any modifications to the text segment. The size of the text segment will always be fixed, and your code will be stored here in the text segment. Then you have data segment, which is further divided into initialized and uninitialized data segment. So data segment can have global variables or static variables stored. So data segments will have global or static variables stored. Then there is heap segment, which is going to have dynamic memory allocation done. So we have something called as dynamic memory allocation, which happens in your programs. That memory allocation happens in the heap segment. And whenever you create a function, there is a stack frame getting created at the stack segment. Okay, so stack frame gets created at the stack segment. Now there will be one common memory between the stack segment and the heap segment, which can be commonly used. So stack is going to grow upside down and heap is going to grow downside up. So it is like a ladder. So whenever you add something into the stack segment, it grows upside down. Whenever you add something into the heap segment, it grows downside up. Now when this point meets together, okay, so we have pointers to take care of it. When these 2 points meet together, it is said that the memory is exhausted. You no longer have the memory is exhausted. So that is about the 4 segments of the memory. The text segment, which is also called as code segment, the stack segment, the data segment, and the heap segment. So you just remember few points. Text segment will have the code return. Stack segment will have the stack frames return for every function you call. Data segment will have the global or static variables stored, and heap segments will have the dynamic memory allocation done. So that is about storage classes. So tomorrow we have something to be discussing about global variables and preprocessors, which we will conclude tomorrow. Okay, so tomorrow will be your last class. Hopefully it has to get over a little earlier comparatively. Let us see how it goes, and tomorrow will be your last session for the C module. Okay, so we will meet tomorrow for the last time to conclude the C module, and that is it for today. I'm going to stop here. Thanks for attending the session. We will continue tomorrow. Assessments will be given, you don't worry, like according to the work you're doing with respect to the project, the assessment will be done. The stack segment is where the memory for the stack will be allocated. I said whenever we did a function call, every time I was drawing a square box and I told you that it is called as a stack. So that stack for every function you call will be created in the stack segment. Okay. Yes. Thank you all. We'll meet tomorrow.